In this issue, we introduce the MagPilot electromagnetic positioning system. As we all know, the commonly used surgical navigation and positioning methods include optical positioning system and electromagnetic positioning system. However, there is a difference between the two. Although the objects have a wide positioning range and type position, they are easy to be occluded, and the electromagnetic positioning system overcomes this problem. The MagPilot EPM51R was released in June 2024. Next, we will introduce the components of the electromagnetic positioning system. The whole system is divided into three core parts: the magnetic field generation, the sensor interface unit, and the system control unit. First, let's take a look at the magnetic field generation, which is a device that generates an oscillating magnetic field throughout the system. Second, the sensor interface unit, which is an extension of the sensor and the system control unit. Finally, let's take a look at the system control unit, which is the commander of the entire positioning system and is responsible for the important tasks of data exchange between the electromagnetic positioning system and a host computer and control in the driving magnetic field. In addition to the above three core units, a key consumable is also required to complete the positioning function, that is, electromagnetic sensors, combined with the actual medical needs. The EPM51I chose a coil sensor, which is more easy to integrate, unquote, effective. At present, there are 35 degrees of freedom sensors that can be provided by AIMOOE. For your convenience, email also provides a variety of standard tools. After talking about the basic components, what is the principle of the electromagnetic positioning system? Integrate the sensor into the surgical tool according to your needs in order to facilitate your use. Email also provides a variety of standard truths. Arrange the magnetic field generator in a suitable position so that the magnetic field covers the surgical space, and the magnetic field generation can emit a controlled alternating electromagnetic field to help obtain the position and posture information of the sensor. When the equipment is working normally, the sensor will generate weak electromagnetic force in the alternating electromagnetic field. The whole system contains precision weak signal amplification circuit to ensure the accurate conditioning and digitization of the signal. The digital signal is transmitted main controller through the system control unit, and post-calculation the target sensor is completed through the mathematical algorithm. The electromagnetic positioning system provides rich hardware interfaces, toolboxes, and a variety of ABAS, supports flexible debugging and secondary development, and realizes real-time navigation. After understanding so many technical principles, everyone must be curious to know what surgical scenarios can the electromagnetic positioning system be used in. In the medical field, with its excellent accuracy, real-time tracking, unknown radiation hazards, EPM510 is widely used in interventional minimally invasive surgeries, such as culture ablation, bronchoscopy, nasogastric catheterization, spinal endoscopy, vascular intervention, etc. Electromagnetic positioning technology has revolutionized medical operations. Now let's find out how it works. The first is the connection on assembly of the various components of the whole system. Use the power cable. One end is connected to the power interface of the DSC, and the other end is connected to the power supply. Use the CUSK cable to plug in component interfaces on a CU and SCU, respectively. Insert one end of the magnetic field generator connector on EFD into the FG connector via CU. Use the data transmission cable. The Type B end is plugged into the Type B interface behind the SCU. An USB end is connected to the computer. Insert the sensor in into us. Power on a device and green LED on. And at this point, the whole set of hardware connection is completed. Make sure that the configured USB driver is installed on the computer. Open the toolbox software. Click Connect. Select the electromagnetic device. Select the USB connection. And connection is successful. In the toolbar in the lower right corner, click Up Does, and the system will automatically monitor the connected to port. Each tool requires a specific tool file to be used. There are three ways to load the sensor control. The first is to automatically read the tool file after the device is connected, and the second is to manually select the tool file. Here is the second method. Click Select Port. Select one of the ports. Click Select 2. The True File Storage folder pops up. find the sensor profile of the corresponding port. And after selecting, the transformation data starts refreshing by default. The positioning view of the software includes 3 views, and the data list view, and the information includes the currently connected port, the sensor true pose information corresponding to the current port, the number of acquisition frames, and the true status. Provide the function of setting reference points. Click the button to see reference points. Select the 60F2 you want to set. Eagle change to the shape of box plus cross on the 3 views, indicating that the current true is the reference coordinate system. Its coordinate information is the system coordinate system, and post information of other truth will be converted into the current reference coordinate system. Click Elect to set the acquisition frame rate and start delay. After starting the acquisition, you can output a collected 2 points, information, and output a data table. Finally, the MyPilot electromagnetic positioning system provides users with 3 operating modes: continuous mode, synchronous mode, in-treat mode. Users can select the corresponding acquisition mode according to the user scenario and cooperate with this system for secondary development.